Hey, so, yes. Everyone, can you see my screen?
Yes.
Okay, thanks a lot. So, I got the message from Josefa that you all have received the assignments yesterday only. Okay, Abdur, thank you. So, okay, that's not an issue. So, please try to complete the assignment today. Okay, and submit the assignment tomorrow. Someone from our team will contact you regarding the homework. Okay, and please share the assignments with them. Okay, and but I guess you can upload the assignments on the portal. Am I correct?
Yes, sir.
Yes, sir.
Yeah. So okay, please complete the assignment and upload that on the portal. I will check it from there. Okay.
Yes, sir.
Okay. Okay. So we will continue our topic. Anyone can tell me that we have completed these two theorems, theorem 2 and 3? I guess we
We
have
did 1 and 2 only, sir.
okay, only 1 and 2. Okay, okay, 1 and 2. Okay, okay, that's fine. So please check please note down the theorem third. The determinant of the product of matrices is equal to the product of their respective determinants. So what does this mean? Just give me a minute. Okay, this means if you have two matrices, two square matrix, and you are multiplying these two. Okay, so that will be equal, and you're finding the determinant of the multiplication of two matrices. We have two matrices A and B. We are multiplying these two matrices, and we are okay. So that will be equal to, if you will find the determinant of the first matrix and you will multiply it with the determinant of the second matrix. Okay, so if you have two matrices and you are multiplying these two, and then you are finding the determinant of this, then that will be equal to the multiplication of the determinant of both the matrices. This is clear to everyone?
Yes.
Okay, Atif, Abdur, Huzefa, Saf, Shravya. This is clear?
Can you explain again, sir?
Yes. So what I'm saying, that if suppose we have two matrices A and B, okay, and we are multiplying these two matrices and then we are finding the determinants. I hope everyone is aware about the who have the doubt in this.
Me.
Okay, okay, Saf, you were there in the last class. Okay, so we are multiplying the two matrices and then we are finding the determinant of this. So this will be equal to, if you're finding the determinant of the first matrix and you're multiplying this with the determinants of the second matrix. This clear?
Yes, sir.
Okay, very good. Then please note down the theorem third and confirm me, then we will start the theorem fourth. Please complete this. Everyone, please confirm me if this is done. Okay. Okay, Atif. Very good. Abdur, Huzefa, Saf, Shravya. Shall we start next? This time? Okay, Shravya, good. Abdur, Saf, Josefa. Shall we start next? Okay, Josefa. Okay, Saf. Okay, Abdur. Okay, very good. Now, next theorem. Okay, next is if A is a non-singular matrix, okay, of order n, then adjoint of A determinant is equal to determinant of A and minus 1. First of all, what is the adjoint? What is the adjoint of a matrix? Shravya? Shravya, can you tell me what is the adjoint of a matrix? Uh, Shravya, you are on mute if you are saying something. Atif, can you tell me what is the adjoint of a matrix? Why everyone is silent?
Sir, can you
Hmm.
hear?
Yes, I can hear you. What is the adjoint of a matrix?
So adjoint of a square matrix is the transpose of the matrix of like the cofactors of each
by
element of them.
using by using cofactor. Okay, very good. So Atif, can you tell me what is a? Yes, Shravya, I did call your name, so not issue. Shravya, can you tell me this theorem? A into adjoint of A. What is the theorem? A into adjoint of A. What is it? Okay, you were not there in that class. Okay, Shravya. Then Shravya, please check the. Okay, then please check the recorded lectures. Okay. Then who can tell me? Seth, can you tell me what is A into adjoint of A?
Determinant of A into identity.
Very, very good. Determinant of A into identity. Okay, Seth, can you tell me what is the order of this identity matrix?
Same as the determinant.
Same as the matrix A. Very good. Now suppose we have taken here order 3. Okay. Now suppose this matrix A have the order 3. So we can write like this: A into adjoint of A is equal to determinant of A, and in place of identity we can put the complete value. Sorry, 0 1 0 and 0 0 1. Okay. Now who can tell me next? Josefa. Josefa, you were there in the determinant class. Okay. Josefa, so there's slight confusion. Actually, during the Ramzan, this class will be for the other batch. Okay. At the same timing, we have another batch in which we were doing the matrices. So in last class, we have completed the matrices in that batch. Okay. But after Ramzan, the timing has been changed. So this is not the same batch. Okay. You can see all the students are new over here for you. So the next batch timing will be almost 1.5 1.5, or we can say, yeah, 1.5 hour from now. Okay, so
Yes, sir.
yeah, so there's another batch. So if you wish, you can continue in this, and please join that batch also, because we will start the determinants in that class. And Shavya, we have another class. We have another batch in which we are doing the determinant from the scratch. So if you wish, you can join that class. So whatever the topic you have missed, you can complete in that batch. Okay. And the same thing is for everyone. Okay. So another batch timing will be uh, 6. So 105 minutes from now. Okay. After 105 minutes, the other class will start. Okay. So we are discussing about this. Who can tell me next? Abdur. Observe, if we are multiplying this determinant with this matrix, then can you tell me what the final answer you will get? Observe, if you are multiplying this determinant with this matrix, can you tell me what the final answer you will get? Observe, yes or no? Those three elements will be multiplied. I guess you want to say that one will get multiplied with this. Please remember, in a matrix, if you are multiplying a matrix with any number, okay, with any constant, with any number, then all the elements will get multiplied with that number. This difference we have already discussed, that if in a matrix you are multiplying it by some number or by a constant, then all the values, all the elements will get multiplied with that number. Okay, but if it in case of determinant, if you are multiplying the determinant by any number, then only a particular row or column will get multiplied with this. Okay, so there is a difference between the determinants and the matrices. Shravya, very good, this is correct. So if we will multiply this, we will get this one, 0 0 0 determinant 0 and 0 0 0 0 determinant. Okay, now we will find the determinant on both the sides. Yes, Shravya, that's correct. We will find the determinants on both the sides. So this is the adjoint of A. Okay, A into adjoint of A determinant. This is equal to determinant. In place of this matrix, we will now write the determinant 0 0 0 determinant 0 and 0 0 determinant. We get this one. Okay. Now, anyone can tell me, here we have two matrices, A and adjoint of A. We have these two matrices. Anyone can tell me if we are finding the determinant of multiplication of this, then on the basis of theorem third, what can we write? Please apply the theorem third on this. A into adjoint of A determinant. Please apply the theorem third.
Do you need to type it in the chat?
No, you can tell me just right now.
So determinant of A into determinant of adjoint.
Very good. So I hope this is clear to everyone. My voice is breaking. Okay, Shravya, please rejoin. Anyone also have the same issue? My voice is audible to everyone.
Yes, sir.
Okay. Okay, Shravya, then please rejoin. So here, if you will check this, then what is the property? If you have two matrices and these are getting multiplied and you are finding the determinant of that, then that will be equal to determinant of A into determinant of B. Okay, so now we will apply this property over here. We have two matrices. A is a matrix and adjoint of A is also a matrix. We are multiplying these two matrices and we are finding the determinant. Okay, so that will be equal to what? That will be equal to determinant of A, determinant of adjoint of A. Okay, A into adjoint of A determinant is equal to determinant of A into adjoint of determinant of adjoint of A. Okay, now next, who can tell me Ceph? Okay, Ceph. So from this determinant, can you tell me what can we take common?
A determinant,
Only a determinant?
an identity.
No, 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 this is not identity. No, only determinant of A. This is incomplete. Anyone else can tell me? Anyone else can tell me what can we take common from this determinant? This answer is correct, Saf. This is correct, but this is incomplete. Okay. Atif, what can we take common from this?
Not sure, sir.
Not sure. No issue. Atif, can you guess?
No,
Atif,
sir.
no. Try to guess anything. What can you take common from here? Atif, you can tell any. You can tell me any of the answer. Abdur, Josefa, Shravya. From this determinant, what can we take common? You can tell any of the answer. Okay, then please tell me in this way. Shravya, from the first row, what can we take common?
Sir, determinant A,
Determinant A, very good. From the next row, what can we take common?
determinant A,
Determinant A, very good. So determinant A we have already taken. Again, we are taking this. From the last row, what can we take common?
determinant
Again, determinant of A. Okay, so what's the remaining value will remain? 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, now here what we will get, determinant of A, adjoint of A is equal to, this is determinant A cube. And please remember the determinant of identity matrix, this is always 1, so into 1. Now if you will shift this A to this side, so we will get this adjoint of A, and this is equal to what you will get, determinant of square. So we get this answer that determinant of A is, determinant of adjoint of A is equal to determinant of a square. And this was a theorem. If you will check the theorem, so theorem is adjoint of A is equal to determinant n minus 1, where n is the order of the matrix. So if you will check in this case, here we have order 3. That's why we are getting 2. So adjoint of A is always equal to determinant of A to the power n minus 1, where n is the order of the matrix. Okay. This is clear to everyone?
Sir, can you explain how we took determinant of A cube?
Yes, this is the major difference between the matrices and determinant. Okay. Abdur, you were present in the last class when we have discussed about the minor cofactor and adjoint. Okay, so we have already done the cofactors. Okay, adjoint is what? Adjoint is nothing, just make a matrix with the help of cofactor and find the adjoint of that. Okay, so Abdur, I guess you have missed some topic in the determinant, so it will be good if you will join the next batch also. Okay, okay, so yes, please try to understand the difference between the matrix and the determinant. Suppose we have this matrix 2, 4, 2, 4, 8, 2, 4, 4, and 4. Okay, so this question is for Atif. Atif, can you tell me what from the first row, what can we take common?
2.
2. From the second row, what can we take common?
2.
2. From the third row, what can we take common?
4.
Okay, so this is 1, 2, 1, 2, 4, 1, 1, 1, 1. Okay, so what happened in a matrix? In a matrix, sorry, we have done something. This was not matrix, this was a determinant. Sorry. Sorry, this was a determinant. Okay. In a determinant, if you are taking common, then you need to take out the common from any of the row or the column. So row wise, we have taken the common. Okay, this is for the determinant. But the same thing will not happen in matrix. Suppose in a matrix, if we have these elements 2, 4, 2, 4, 8, 2, and 4, 4, 4. Shravya, my voice is breaking. Everyone, my voice is audible, or is there an issue? Everyone, my voice is audible. Is it fine? Atif, Abdur, Zephyr, Saf. Okay, now okay. Okay, Shravya, then I will switch off the video. Okay. Okay, so what we are discussing in a determinant, if you are taking common, then you need to take a row wise or column wise. But the same thing will not happen with the matrix. Suppose from this matrix, if we need to take out some common, then we will take out the common from all the elements of the matrix. So for example, we will take out common 2 only. So what we will get? 2, 2, sorry, 1, 2, 1, 2, 4, 1, 1, sorry, 2, 2, and 2. Please remember this, okay? If you are taking a common from a determinant, then please take out row wise. If you are taking common from a matrix, then we can take only 2 common because we need to take out the common from all the elements. Atif, this is clear?
Yes, sir.
Okay. Now, if you will apply the same concept. Okay, I'm sorry, I have just switched off my video. There might be some network issue at the Shravia's end. Okay, so now in the first row, if we will take out the common, so Atif, can you tell me what can we take common from the first row?
Determinant of A.
Determinant of A. From the second row?
Determinant of A.
From the third row?
Determinant of A.
That's why we are getting determinant, determinant, and determinant. This clear?
Yes, sir.
Okay, everyone, this is clear? Abdur, Huzefa, Saf, Shravya, this is clear to everyone?
Yes, sir.
Okay, okay. Great. Please note down this, confirm me. Okay, and please learn all these theorems. Okay, if you wish. Okay, so please note down, learn all these theorems. We will use these theorems in the numericals in some questions. So please complete this and let me know, then we will start the further questions. This is when. Shall we start next? Atif, Abdur, Huzefa, Saf, Shravya. Okay, Atif, good. Abdur, Huzefa, okay, Shravya, good. Abdur, okay, Huzefa. Abdur and Saf, this is done. Shall we start next? Abdur and Saf. Abdur and Saf, shall we start next? Okay, Saf, very good. Abdur, so we are going. Okay, Abdur, very good, great. Now next, this is a very important topic, inverse of a matrix. Okay, this is a very important topic. Most of the time, one question always asks from this topics. Okay, so inverse of a matrix, what is mean by inverse? So first of all, we will check the definition. Now, the definition is a square matrix of order n is invertible if there exists a square matrix B of the same order such that AB is equal to B is equal to I. We will understand this. Suppose A is a square matrix. Okay. A is a square matrix. First of all, we will see that what is meant by invertible. Always remember, if the inverse of a matrix exists, then we will say that this matrix is invertible. Okay, I will again repeat this. Invertible, we will say a matrix is invertible if its inverse exists. What is inverse? We will discuss later on. First of all, please understand what is invertible. If the inverse of a matrix, we are talking about the square matrix. Okay, so if the inverse of a square matrix exists, then we will say that the matrix is invertible. Okay, this is the last time I am explaining you. Invertible, if the inverse of a matrix exists, we will say that the matrix is invertible. Okay, now what is the inverse of a matrix? Suppose we have a matrix A, we are multiplying this matrix with B and we are getting identity matrix. Okay, what is the order of the identity matrix? The same order as that of A. What is the order of B? Same order as that of A. So if we have a matrix A, we are multiplying that with B and we are getting an identity matrix, then we will say that B is the inverse of A. Just give me a minute. Suppose A is the matrix. Okay, we are multiplying this with a matrix B and we are getting a identity matrix. Then we will say that B is the inverse. B is the inverse of A. Okay, this is clear to everyone. What is mean by inverse of a matrix? Atif, Abdur, Josefa, Saf, Shravya. How we will find the inverse, we will see later on. But first of all, please tell me, is this clear that what is mean by inverse of a matrix?
So please
Yes.
say again.
This happens
Yes.
only when inverse of matrix exists.
Shravya, will you please repeat your question?
Sir, this only happens when inverse of matrix exists.
It only happens means AB
I
is
mean,
equal to what?
invertible matrix.
Yes, yes. When a matrix is invertible, when its inverse exists.
Okay, sir.
Okay. If its inverse do not exist, then definitely this theorem is not valid for that. So we are just talking about the cases where the inverse will exist.
Yes.
Okay. Okay. So I will again explain to you. Suppose we have okay. We will compare in this way. We have a number 2. Okay. We are multiplying this with some number and we are getting a 1. So whose doubt was this? Seth, I guess. Seth, can you tell me with what number we will multiply this 2 so that we will get a 1?
Half.
1 by 2. Okay, reciprocal of that number. Now, similarly, try to understand this, that we have a matrix A. Okay, we need to multiply this another matrix so that we get a identity matrix. So if we are multiplying this matrix A with B and we are getting identity, then we will say that B is the inverse of A. B is the inverse of A. So what is the definition of inverse of a matrix? This is the definition. That what is meant by inverse? If we will multiply this with another matrix and we are getting identity, then this matrix B is called the inverse of A. This
Yes,
clear?
sir.
Okay. Now, how we will represent it? This, we will represent this inverse like this, A inverse. If we are finding the inverse of A, then that will be denoted by A inverse. So as we are saying that B is the inverse of A, that's why we will write B is equal to A inverse. This is clear.
Yes, sir.
Anyone have a doubt in it? This is a very important topic. Okay. And every year one question came from this topic. So if anyone have a doubt in this inverse, then please let me know because we need to solve the equations by using inverse. Anyone have a doubt in this?
Sir, if
Side.
B is equal to A inverse, can you also say that A is equal to B inverse?
Yes, yes. Very good. This is a very good concept that we are saying that AB is equal to I. Okay. Now we are saying that B is the inverse of A. We can also say that A is the inverse of B. Okay, Atif?
Okay, sir.
Okay, very good. So silence means no doubt. So I hope this is clear to everyone. Okay. Please note down this, confirm me. Then we will see some theorems on the basis of this and we will try to solve some questions. Okay. Please complete this and let me know. Okay, Abdur, very good. Atif, Huzaifa, Saf, Shravya, this is done.
Yes, sir.
Okay. Shravya, Saf, Huzaifa. Okay, Shravya, good. Huzaifa and Saf, this is done. Shall we start next? Saf and Abdur. Okay, Abdur has completed this. Okay, Saf, very good. So I hope this is clear to everyone that what is the inverse of a matrix. Okay, if we are multiplying that with another matrix, if we are multiplying A with B and we are getting I, then that means B is the inverse of A. We will check a theorem on the basis of this. A square matrix A is invertible if and only if A is non-singular matrix. Okay. Now, we already said that what is invertible if its inverse exists. Now, this theorem will tell us that inverse of a matrix exists only if A is non-singular matrix. Okay. Shravya, can you tell us that what is a non-singular matrix? Shravya, can you tell us what is a non-singular matrix?
So the one that has same order.
That has same order. No, that's a square matrix. Okay. We are talking about non-singular. So, Seth, can you tell me what is a non-singular matrix?
Whose determinant is not 0.
Determinant is not zero. Very good. So, a square matrix, inverse of a matrix exists if it is non-singular matrix. Okay. Okay, Shavya, no issue. So, first of all, this is the theorem. Now, we will again go back to A into adjoint of A. Who can tell me? Josefa. Josefa, what is A into adjoint of A? We have already done this theorem. Very good. Determinant of A into I. Very good. Okay. Good, Josefa. Determinant of A into I. Please multiply this with the identity. Now, if we will shift this determinant to the left side, so we will get like this: A into adjoint of A, and in its denominator we can shift this determinant, so this will be equal to identity matrix. So A into, this is 1 by determinant of A, adjoint of A is equal to I identity matrix. Okay, So I hope this is clear to everyone. Okay. And in maths, always remember in denominator, we never have a zero. In complete mathematics, please remember in a denominator, you should never get a zero. Otherwise, that will become not defined. So here in the denominator, we have a determinant. Leave that topic. Here we have a matrix A, and anyone can tell me that this complete one is what? This complete is a determinant or this is a matrix, the complete expression.
Matrix.
Matrix. Okay. Anyone else? Anyone else? I'm asking about this complete expression. This complete one. 1 by determinant adjoint of A. Everyone, please. Matrix. Okay, Shravi, I got your answer. Anyone else? Please try to guess. Okay. If you don't know the answer, not you should try to guess. So you have only two options. Either this is a determinant or a matrix. Abdur, Huzaifa, and Saf. Please tell me the answer. Okay, Saf. Huzaifa, Abdur. Determinant or matrix? Huzaifa and Abdur. Okay, Abdur. Huzaifa. Huzaifa, determinant or a matrix? Huzaifa, no reply means neither determinant not a matrix. Huh? Okay, so all of you, your answer is correct. This is a matrix. Okay, because adjoint of A is a matrix, you are dividing that with a number. So the answer will be a matrix. Now we are multiplying A with this and we are getting identity. So can we say that this is the inverse of A? Can we say that A inverse is equal to 1 by determinant of A adjoint of A? This point is clear to everyone. You're multiplying matrix A with this complete one. And you are getting an identity matrix. So you can say that this complete one is what? Inverse of A. Is this correct or not? Atif, Abdur, Huzaifa, Saf, and Shravya.
Yes.
Okay. Okay, Abdur. Okay, Huzaifa. Saf. This is correct or not? Saf, yes or no? Okay. Okay, this is correct. We are multiplying these two matrices and we are getting identity. So we can say that this is an inverse of A. Okay, now please check this. Determinant of A is in the denominator. When this complete expression will exist, when this determinant of A is not equal to 0. Because we have already discussed in mathematics in a denominator, we should never get a 0. Okay, if we will get a 0 over here, then this becomes not defined. So when this complete expression will exist, when the denominator will not be equal to 0. And what is in the denominator? We have a determinant of A. So determinant of A is not equal to 0. Hence inverse of matrix A exists if it is non-singular matrix. If it is non-singular matrix. So Shravya, you have asked one question that we need to check the theorem or that expression for the matrix of which the inverse exists. Okay. Yes, we only apply that theorem on the cases in which the inverse exists. And how do you know that the inverse will exist? This is the condition. You will always find the determinant of that matrix, and if it is not equal to 0, then the inverse of that matrix will exist. If determinant is equal to 0, then you can find the inverse. Okay, so everyone, this is the proof of the theorem. What was the theorem? A square matrix is invertible, or we can say a square matrix inverse exists if it is non-singular. So we have done this derivation. In the end, we can say that this expression will exist if the determinant is not equal to 0. Hence, inverse will exist if it is non-singular matrix. Okay. So I hope this is clear to everyone. Please note down this, confirm me, then we will try some questions on the basis of this topic. Okay, please complete this. Okay, Abdur, very good. Atif, Huzefa, Sav, Shravya, please confirm if it is done. Okay, Shravya, good. Okay, Atif, very good. Sav, this is done. Shall we start next?
1 minute, sir.
Okay. Okay, sir, very good. Okay, so please note down this, and after I'm going to erase this. If anyone has left, then please let me know. Okay. I hope everyone has done this. Now, please note down this point that this theorem provides us a formula for finding the inverse of a non-singular matrix. And inverse is given by this one. Okay. So in the previous derivation, we have checked this formula. Okay. By the use of this one, we can find the inverse of a matrix. So please note down this statement and this formula. I will give you just 1 minute for this. Okay. Okay, sure, we are good. Atif, Abdur, Huzefa, Saf. Okay, Saf, you have completed. Atif, Abdur, Huzefa. Shall we start next?
Yes, sir.
Okay. Abdur,
1
Huzefa,
minute.
Saf. Okay, okay, okay. Okay, please message me once it is done. Saf. Okay, okay, good. Okay, we need to find the inverse of this matrix. Okay, so first of all, what is the condition? What condition we need to check, Saf? In which case the inverse of this matrix exists? Saf?
Yes.
Yes. How can we check that the inverse of this matrix exists or not?
You have to check if it is equal to identity.
No, 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 no. Anyone else? Shravya? How can we check that the inverse of this matrix is exist or not?
So whether it's invertible or not.
How can we check it is invertible or not?
So invertible means if inverse of matrix exists.
Yes, but
If
how?
the determinant of A is not equal to 0.
Very good, very good. Okay, so first we need to find out the determinant of this matrix. If you will find out this 4 to 8 and plus 3, this is equal to 11. So this is not equal to 0. Hence, the inverse will exist. So whenever you will get a question, please find the determinant of that so that you will came to know that inverse will exist or not. Okay, so determinant is not equal to 0. So that's why this its inverse will exist. Now, what is the formula of finding the inverse? This is equal to 1 by determinant of A into adjoint of A. So everyone know how to find the adjoint. So please find the adjoint of this matrix and divide that with the determinant. You will get your answer. Okay. Please complete this question and let me know. Everyone, please hear your answer once it is done.
2 minutes. Sir.
Okay. Okay, Atif, you get the answer. Good. So Atif, this is the answer minus 4 by 11, 1 by 11, minus 3, and 2 by 11. Very good. This is correct. Okay, Shavya. Okay, Abdul, I will. Okay. Please check here. So Abdul, we have already find out the determinant. Okay, determinant is what? 8 plus 3, which is equal to 11. Okay, now we need to find the A inverse. So what's the formula of A inverse? 1 by determinant of A, adjoint of A. Okay, so for the adjoint of A, first of all, we need the cofactors. A1. You're getting minus 1 by 11. Shravya, I will solve this. Okay. Now A11. A11 means this. Okay. Who start this? Abdul, can you tell me what is A11? Cofactor. Cofactor of the first element. Abdur, can you tell me what is the cofactor of the first element? Abdur, do you know about the cofactors? We have discussed that in the last class. If not, then please check here. A11 is equal to, always write -1, 1 plus 1. Okay, whatever the number you have over here, you will write here 1 plus 1. After this, please ignore the first row and the first column. Then the value is 4. So we will get this is equal to 4. For A12, again write -1 to the power 1 plus 2. Now for this case, please ignore the first row and the second column. First row, second column. So you will get 3, which is equal to -3. Next is A21. Okay, this is equal to what? Second row, first column. So this is -1, 2 plus 1. Second row, first, okay, ignore the second row, first column. So remaining number is -1, which will give you 1. A22. So this is equal to second row, second column, remaining is 2. So -1 to the power 2 plus 2,
Got
which
it,
will,
sir.
okay, very good. You will get 2. What is the adjoint of A? Adjoint of A is equal to transpose of this one, A11, A12, A21, A22, its transpose. This is equal to A11, A12, A21, A22. Okay, now put the values over here. So you will get A11 is 4, A21 is 1, this is -3, and this is 2. So adjoint of A, okay, no issue. Okay, Shavya. So we get this one, 4, 1, -3, 2. 4, 1, -3, and 2. Next, we need to find the A inverse, which is equal to 1 by determinant into adjoint of A. So this is equal to what? 1 by 11. And adjoint is what? 4, 1, -3, 2. 4 by 11, 1 by 11, -3 by 11, 2 by 11. Okay. We have a doubt in this. Abdur, this clear now? Okay. So I hope this is clear to everyone. Josefa, Saf. Josefa and Saf, this is clear? Okay, Josefa. Saf, this
Yes,
clear?
sir.
Okay, very good. So everyone please note down this and confirm me. Shall we start the next question?
Yes.
Okay, very good. Then please start this question. Okay. If A is equal to this, then verify A into adjoint of A is equal to determinant A into I. Also find the A inverse. Okay, please try to solve this question on your own. I will be back in 2 minutes. Okay, please solve it. Hello everyone. I hope all of you have completed this question. This is done. You
No,
need
sir.
to. Okay. Anyone have facing any issue in this?
This question is a bit lengthy, sir, like the adjoint will take away.
Yes, you are correct because the order is 3 by 3. Okay. In exam, most of the time they ask from the order 3 by 3. Okay. So it is better if you will practice these types of questions. Okay. So I will wait. Please continue and share your answer.
Sir, how to find a minor of 3 by 3?
Sir, the same method. Okay, I will tell you this. I will write here. So M11. Okay, so 11 means first row, first column. Ignore the first row and the first column. What the remaining value you will get? 4, 3, 3, 4. Okay, this is equal to 16 minus 9, which is equal to 7. But this is a minor. We need the cofactor. So cofactor is what? -1, 1 plus 1 into M11. So -1 square, M11 is 7. So again, 7. This clear, sir?
Yes, sir.
Suppose if you need to find M12, then first row, second column. First row, second column. So 1, 3, 1, 4. 4 minus 3 is equal to 1. Okay, so cofactor will become what? A12. This is equal to -1, 1 plus 2 into 1, which is equal to -1. Similarly, please find all the cofactors, then adjoint, then put in this. Okay, Atif, let me check your answer. So 7 minus 3 minus 1 minus 1. Atif, I guess this is correct. Okay. So this is adjoint. Please find the A inverse. What is the determinant you are getting, Atif? Oh, okay, Shavya, let me check. 7 minus 3 minus 3. This is correct, Shavya. Please check the second line. Good. This is correct. What's the third one? Very good, Shavya. This is correct. So what you need to find now, please find the determinant. Okay. And then find LHS and RHS. Please find the determinant of this. Please find the determinant of this, okay? Okay, Shrav, you're very good. You're getting determinant 1, that is correct. Now please verify this one. This LHS, this should be equal to RHS. Please verify this. Okay, and then find the inverse of it. Anyone have a doubt, then please let me know. Sav, this is not correct. Okay, so I will just find the determinant of this matrix. This is what, as you already know, that we can expand it along the first Atif. That's correct. Very good. So, Sav, as you know that we can expand the determinant along any row or column. So, if you will expand this along the first row, then this will become what? 1. Write the remaining values 4, 3, 3, 4. 3, 4. Then minus 3. Okay, you know why we are putting the negative sign here. So this is 1, 3, 1, 4. And plus 3. And this is 1, 4, 1, 3. So determinant of A is equal to, solve this, 16 minus 9. Okay, minus 3, 4 minus 3. And this is plus 3, 3 minus 4. So this is equal to 7 minus 3 minus 3. So this is equal to Okay, Seth, please again check the calculation. And Atif, very good. You have completed this. So all of you, please complete this one. I hope everyone has find the adjoint of this. Now please multiply A into adjoint of A. Okay, Shravya, very good. So Shravya, can you tell me what is A inverse? Because we also need to find A inverse. Okay, Shravya, please tell me.
Sir, I'm solving the last part.
The last part means you have verified this one.
I multiplied A into adjoint A, so I got identity matrix.
Very good. Now, can you tell me what is the because they are saying that find inverse, A inverse. So can you tell me what is the inverse of it?
Yes.
Yeah. Please find that and share your answer. Okay, there's no need to do any further calculation. From this expression only, you will get the value of A inverse. Okay, sure. Very good. And all the other students, please complete this one. Okay. Yes, Shavya, can we say that that is equal to, no, not correct.
Sorry, sir. I wrote it again. I'll write it again.
Yeah. Can we, okay, please do it. And Abdul, Huzaifa and Seth, if you have any doubt in this, then please let me know. Okay. That's correct.
Done, sir.
Okay, good. Very good, Shavya. This is correct. This is the inverse. Abdul, did you find the adjoint of A? Abdul, you get the value of adjoint? Abdul, yes or no? Do you get the value of adjoint? Why, Abdul? What's the issue? Did you find the cofactors? Abdul, did you find the cofactors? You need to find the covectors in the same way, okay? Please find A11 as I've done this. Find A12, A13, and so on. First of all, please find the adjoint of it. Okay. Zephyr and Seth. Very good, Shravya. This is correct. Very good. Zephyr and Seth. This is done. Okay, very good, Zephyr. So are you getting the same answer? This is okay, Seth. Very good. Okay, so this is also the inverse of A. So please check the answer. Abdur, did you get the value of adjoint? Abdur, do you get the value of adjoint? Okay, very good. So are you getting the same answer? 7 minus 3 minus 3?
Yes, sir.
Okay, very good. So Abdul, can you tell me what is the value of inverse, A inverse? Abdul, what is the value of A inverse? Okay, I will ask you one by one. Abdul, first of all, this part has been done. This is verified. Abdul. Okay, very good. We got it. Okay, so this is the inverse of A. Very good. So I hope everyone has completed this. Okay, we will now check the next question. Next is you have this matrix A, you have this matrix B. You need to verify that A into B inverse is equal to B inverse A inverse. Okay, so first what you need to do, please multiply these two, AB. Then find the inverse of that. That will be LHS. In the RHS, find the B inverse, multiply that with A inverse, and prove that LHS is equal to RHS. Okay, please start this question and let me know if anyone have a doubt in this. Okay.
So could you repeat again? I got disconnected.
Okay. So we have these two matrices A and B. We need to verify this. So what you need to do in the LHS, first of all, multiply these two. Okay. Then whatever the answer you will get, find the inverse of that matrix. In the RHS,
Yes.
first find the B inverse, find A inverse, and multiply B inverse with it.
Got
Okay.
it, sir.
Okay. Hey, Ravia. Okay, good. Now, similarly, please find the second one, RHS. Zephyr, yes, you can get. Okay, you can contact Amir sir regarding that. Okay, he will share the link with you. Okay, or if you wish, we have a first class of determinants after 30 minutes from now. So if you wish, you can join that class on the same ID. Okay. Then please contact Amir sir. He will give you the link of the recording. Okay, sorry everyone, almost the time is done. So this question number third is your homework, and I will check all your homework. So please complete the homework and upload that on the portal, and I will download your homework from the portal only. Okay, so please give me a minute. I will give you the homework. So homework is assignment 1. Okay, 1, 2, and 3. Okay, the questions were based on the previous topic. After that, assignment 4. Question number 1 to 4. And in the previous classes, I have give you some specific question from the slides only. Okay, so please complete that, and we will continue this topic tomorrow. This question number third is homework. Okay, so we will continue this tomorrow. Okay then, thank you.
Thank you.
Okay, thank you.